Okay, have a seat, please. Today I'm going to talk about the rubric and some important reminders. So, reminder, listen, sit here somewhere close, please. Open your laptops, you might need your Padlet soon. Some reminders, this Friday will be the IA draft. Whatever you give me on Friday, that's the one that I can help you with. Anything other than Friday, you're on your own. So I wash my hands clean. I can only help you with whatever you give me by Friday, December 12th. What else do you have on that day? Nothing, right? No, TOK is December 13th. 12 is Thursday, yes. I move it to Thursday, I forgot, because Friday you have TOK. Okay. And then another reminder, if you're a calendar person, January 20th is the final submission. So if you give it to me on Thursday, I will return it to you by Monday with my comments. Okay? And then this January 20 seems like too far from today, but that's 1 week after we're back in school. So make sure that you finish your data collection during the break or before you leave for summer, for Christmas. So January 20 final submission. Um, Although your batch doesn't really abide to the deadlines, I'll just tell you whatever you give me by 20, that's what I'm gonna grade. It's because unlike EE, I don't have patience for IA because I also have chemistry class. Some teachers only have to grade 5 or 6 IAs. I have to grade bio and chemistry also. You may submit it late if you don't have a choice, but my brain is not going to be as clear and focused when I grade it, so I might not give you a high score. So that's January 20. Now, this IA is total score. Highest score you can get for your IA is 24 marks. And your IA is 20% of your final score. So as I've mentioned before, you can get a perfect for that 20% because you're guided into writing it. I will try my best to guide you, but again, there's nothing to guide you with if you're not giving me anything. So 20% of your score is gonna come from your IA. And where will this 24 marks come from? So if you go to your Padlet and you click IA rubric, so grading you is not a secret. There are 5 components to your score that will generate 24 out of 24. So let's look at it together. Internet should be faster because we have absent people. Okay, so first component is personal engagement. This is an easy 2 marks. It's basically, is your experiment original? If it's not original, did you try to come up with your own research question? Did you modify the procedure? This is where I can also comment on whether you're really engaged with your topic. Sometimes I try to lie here, like, oh, the student is really. But you have to give me some evidence that you know what you're doing. So if you've noticed when you were in the beginning of looking for your research question, I was really with you, guiding you. But when you started collecting your data, I wanted to give you the freedom, liberty. I was not really telling you, oh, don't do this, do that, right? I was allowing you to make your mistakes because that's how I analyze your engagement. It may not be, it may seem that I don't know what you're doing, but I have an instinct. Like, does this student know what he or she is doing? Even if you come to me with so many questions, that's good. That's an evidence that you're really thinking through your experiment. You're engaged. That's why it's called personal engagement. You can also prove your engagement in the beginning of your introduction. Remember when you can write in your introduction personal curiosity. So what led you to doing this experiment? You can explain there. So that's an evidence of personal engagement as well. Okay, next is exploration. So this is the first page 2 to page 4 probably of your IA. This is where you have your discussion background information, right here, background information. Remember when I was telling you, provide scientific context about your study. Talk about the independent variable. Talk about the science behind what you're doing. The topic is identified, fully focused research question is clearly described. This one, it's easy to get this because in your paragraph, you put research question, then your research question. Also in the introduction, you write prediction. You write your prediction, you back it up with science. That's focusing your research question. Methodology. So this is talking about your table of variables. Did you identify your controlled variables in detail, the significance? Do you have a stepwise procedure? In other words, I've been reminding you, a stepwise procedure is if somebody else is reading your experiment, they can replicate it as it was without you explaining to them how to do it. So procedures should be detailed and stepwise. This is easy to lose. This is easy to lose. Shows evidence of full awareness of significant safety, ethical, environmental issues. Even if there's no safety or environmental issues in your experiment, remember I told you before, mention it. Like my experiment does not include any safety, whatever procedure. I'm not using chemicals. This is also where you put those who will use participants. This is where you put a participant waiver form will be signed before the participant can join the experiment. Okay? All right, analysis. Next component, 6/6 again. Analysis, first component for analysis is they are looking at how you're recording your data. That's why last week I asked you to give me your proposed data table. So does your table have uncertainties? Does your table have the average, the standard deviation? Does your graphs have error bars? So how you are recording your data. Next is, it says appropriate, sufficient data processing is carried out with accuracy. So data processing is under every table or graph, if there's a number there that needed calculation, make sure you have a sample calculation. For example, average. That's common sense, but you will still want to put sample calculation for average, sample calculation for standard deviation. So anything that you calculate, make sure you have a sample calculation after the table. This is also where you mention that, for example, you have your final graph. Then you mention a t-test will be performed to figure out blank. Or ANOVA will be utilized to blank. So when you say your statistics, that's analyzing the data that you just gathered. Okay? And then here, the report shows evidence of full appropriate consideration, uncertainty of the analysis. That's your standard deviation, that's your error bars, that's your plus minus. So every time you have those plus minus, error bars, standard deviation, make sure you comment on it under the table so they're aware that you're aware that your data is not perfect. You're just collecting it from experiment, you're just collecting it from database, so there might be sources of errors there. Feel free to comment on that. And then, the last here, this is common sense. So in your process data, if it shows that male has higher, for example, male has higher performance in the long-term memory test, obviously your conclusion will say males. But believe it or not, I have some IAs before. After I read in the ANOVA, it says there's no statistical significant difference. And then their conclusion says it's really different. Like the averages from the 5 independent variables are all different. And then they put an arrow. But in your ANOVA, you said accept the null hypothesis. So just make sure that your process data and graph supports your first line in the conclusion. Okay? And then evaluation. This is where you may lose a lot of marks because by January 20, you're too tired of so many requirements that day. On that day, you also have business IA. So your evaluation is just one short paragraph. You lose marks here. Evaluation should be at least 2 pages. How many? Two. The more errors you find in your experiment, the better, because they know you know what's happening, and you're not like manipulating your data to answer your research question. To some extent, it won't answer your research question. So write it there. What could have been the sources of errors?
If there are too many errors, then won't they say like maybe the student wasn't really good
No,
at making a
not really, because when you were doing your research question, I should have caught that. Remember when you're doing your pre-test, I say, change it. In the pre-test, we should have caught those significant errors. You've caught it already. You've changed milk to apple. So those, you can still write as many weaknesses as possible. Just make sure those weaknesses could have been avoided in the pre-test. It's the purpose of the pre-test. Okay, where am I? So, a detailed conclusion, weakness, and improvement and further investigation. So, in a nutshell, because maybe you're 20% daydreaming right now, evaluation is the back of your CER form. Claim, evidence, reasoning. Then you have a table for weaknesses and improvements. It's exactly the back part of your CER form. Okay? And then you have a freebie component here. Well, not really a freebie. Communication. Is it easy to understand your IA? Are you using subject-specific terminology? Like, does it sound like a lab report and not a literature analysis? So, use of subject-specific words, concepts, okay? And it's easy to follow your IA. When you will soon realize when you're collecting your data, some of you may have really long raw data. Put it in appendix so that it's easy to follow your final table. I can only see the final table or the final graph, and the rest of the unnecessary raw data, just put it in appendix. You can also put diagrams and pictures along the way, everywhere. There's no one place you can put the picture. I would suggest probably in the procedure, you should you should give them some pictures for them to understand how you collected your data. Okay, so let's look at an example here. Questions with the rubric, 24 out of 24, 5 components. So let's look at an example. After this. Okay, so let's say you have your tables already. Let me start with the tables. Most of you have proposed data tables already. Just a quick reminder for your tables, make sure you have descriptive titles here. Okay, some of you are not used to descriptive titles. You just put table 1 ice or table 1 male. Put a descriptive title. What's missing here in the column title? Plus minus, plus minus. What's wrong with 9.4 and 12.8? Rounding. And then standard deviation. Okay. Notice how he has qualitative data. You may insert a qualitative data. It will explain. Let's look at an example. Anybody doing like color change? You're doing color change, you're doing color change. So you can have like a paragraph of how did it look like before, how did it look like after, how long did it take. before the actual number. So you can provide qualitative data, especially if you're looking at, again, physical change of physical observable changes. Okay, so after that, he has a table here of the average and standard deviation. Notice that there's a sample calculation. You don't have to show the calculation for all, just one sample calculation. And then the graph. Every time, this is not in many of my sample IAs, but please remember, every time you have a graph or a table, write a short descriptor under the table. Like for example, this one. You can put a descriptor here. So you can say the table clearly shows that the number of cards that were memorized using printed material was higher than the score when students look at this. So just a one-line descriptor here. You remember, you can also comment on standard deviation. It also shows that on top of this being higher, it also has a smaller standard deviation. So your trials here are more precise compared to this one. Okay, this graph has a description, so that's good. The graph clearly shows that all participants memorize more numbers of cards. So something short here. Okay. And then here, I really like how he transitioned to, this was the final graph. Remember when I talked about error bars overlapping? So he said, however, this graph shows that the standard deviations overlap. This means the distribution is spread out. Therefore, to further find out if there's statistical significant difference, a paired t-test will be used. And then you follow the statistics that you're going to use. Okay? Then discussion here. So conclusion, claim, evidence, reasoning. For many of my samples, please don't do this. Please don't forget. Many of my samples, the conclusion is lacking numbers. This, what do you mean? When we're doing our lab report CER form, so we have your claim, that's the answer to your research question. Evidence, you should discuss your data. So in this independent variable, I'm actually looking at numbers here. But miss, it's in the table already. I know, put it into your final conclusion. So give me the numbers. This one was not, I don't know why. This could have been a higher score then. So claim, what's your answer to the research question? Evidence, discuss your data. I should see numbers. Reasoning, this is where you're too tired to include reasoning because business IA again is due. Look at how he has science here. So you have an answer to your research question. Make sure science can support you. So according to, he mentions here, according to this author, paper readers have better performance due to greater self-regulation. So fancy. Learned in EE, quoted in Nikolai. In addition, in the research conducted by, so at least two science explanation to back you up. If there's none, you can even mention there's not a lot of literature done on this topic. You can have that. But for sure, you can find something that relates to you. Miss, is it okay if science disagrees with my results? Yes. So for example, this is your conclusion, right? So you have a conclusion. And then your next paragraph will say, although this experiment shows that blank, other studies demonstrate blank. That's just telling the truth. That although your experiment says apple is red, many literature said apple should be pink. Okay? And then you transition into your evaluation. So what could have been the sources of your errors and what could have been the sources of your errors? Sorry. So weakness, significance, and suggestion for improvement. This should look familiar from your CER form. But you're like, Miss, hold on, what's that? Strength. This is also in your CER form. Before you discuss all of your weaknesses and sources of errors, mention a strength. Did you have enough database? Did you choose countries from at least one per continent? Did you have enough trials? In your data, did you not, are most of your data precise? You didn't have any uncertainties? Talk about your method. Was it easy for the participants to understand? Or they were getting used to the method, so it may have resulted into biased results. So talk about your strengths there. More than one is good. So going back to CJ's question, if you think you're going to have a lot of weakness, make sure you mention several strengths as well. Okay? Put this in a table form, so it's easier for me to grade and it's easier for Ivy to look at if you're analyzing several components. So weakness, significance. See how there's science behind significance? Well, this will look like your controlled variables. If you remember your controlled variables, so controlled variables here, significance, how to control. For this one, weakness, what's the significance of that weakness? So what if you didn't measure the initial heart rate? So what? Then you put there, well, according to blank, you should have controlled the blank. For example, you didn't control the gender. For you, for example, you didn't control the gender. You will say, according to BMJ, males will have more sensitive sense of smell. So suggestion for improvement, next time, participants should all be from male. Okay. So weakness, table of weaknesses in the table form. And then don't forget further investigation. This is the same as your CER form again, the very last part of your CER form. Suggest any other experiment. Do not suggest how to improve your IA. Suggest other related experiment that can branch out from your experiment. So for example, or if you're testing alcohol-free or alcohol-based hand sanitizer, maybe you can suggest a study on the use of antibacterial soaps. That's also for disinfectant, something like that. So suggest an extension, other experiment. You can even suggest database right here. He suggested database. Okay, and last but not the least, don't forget your works cited page. Do you know how to do it already, right? Before I stop talking, let me look at one more example. Let's see if you remember what I was just talking about. Okay, let's start with this one. Table of control variables. What's missing here in the significance?
Or scientific. No, like according to.
Scientific explanation,
What?
right? So amount must be the same. Why? Why does it need to be the same? Well, if they have different amounts of mouthwash, obviously, if B is not as effective, but there's more of it, then maybe that's why we have a different result. For the significance. Yes, yes. For same one. For the size of the meat, if it's a simple explanation, you don't need. So you can just say, for example, size of the meat, it needs to be controlled because, just say why. Because if they have different starting amounts of meat, then the enzymes can work differently. Even if enzyme 1 was stronger, but the meat was larger, then it's not going to be as effective. So you get it? If the explanation is common sense, just explain why. But if the explanation is not common sense, then you can put, because science say this, so I have to do this. What's good here? Diagram, because it's hard to explain how you streak the agar plate. here, definitely. I put it there, very good. Safety, okay? Safety issues or environmental issues. What do you call this table? Starts with a Q.
Qual. No,
Qualitative. Qualitative. You can have descriptions, remember, like pictures, descriptions. So your um, qualitative data can be a paragraph explaining or a table with pictures. So she provided pictures first before she started giving her, um, actual data collected here. What's missing in this table? Well, what
And
else?
then the rat.
What else?
Oh, it's good. The description.
Description. There should be a short description. Which one is highest? Which one is lowest? Comment on the standard deviation. Very good. How about here? Description again. Wow, this one used ANOVA plus t-test. So maybe think of your data. You may do that. Compare everything. So that's ANOVA. And then do a paired t-test. Maybe the top two highest. Or your highest and your controls. You can do several analysis if you want. What is missing in conclusion? Numbers. Yeah. I wonder why. Maybe the example I gave them didn't have numbers too. My bad. So if I use your IA as an example, there should be numbers, okay? So I've been telling students to look at previous, to look at previous. I didn't catch that one. Um, what else is missing? Just for the first part of the conclusion here. Literature. I don't see like according to. She did try to explain on her own. I don't care how you explain. I want to care if literature supports you. Okay.
It's better for
Um. So her table evaluation. Yeah, I think that's good. And then the bibliography. So that's it. You're on your own again. Friday will be the. Wait, let me end this.